Hello everyone, and today we're going to talk about how malware, computer viruses, botnets, and other programs communicate. Basically, first of all, we have our malware. So the whole video is gonna be in a form of diagrams. I'm gonna present you the architecture and explain the design choices and other things that come into designing on communication channels of malware. So let's say we have our bot or agent or virus, or however you want to call it. So the simplest design is here we have a C2 server, and basically the agent reaches out to the C2 server. That can be through HTTP, WebSockets, or you can use a TCP connection and on top of it build your own protocol, whether it's binary or something plain text. Doesn't really matter as long as you don't introduce vulnerabilities in that protocol. Binary protocols especially are notorious for issues like buffer overflows, etc. So here when law enforcement wants to take out this kind of a device, what you as law enforcement can do is basically, if this is hosted on a domain, you can work alongside DNS providers to basically transfer ownership of that domain onto you, or you can, if it's a raw IP, then you can even get in contact with ISPs, which are internet service providers, and take ownership of that IP address, meaning that all of the traffic will be routing to your own server, and that's called sinkholing a botnet. Or you can either, for example, if it has let's say every C2 server needs a database, and that can be MySQL, SQLite, Postgres, doesn't really matter. We're just gonna call it a database, and the C2 server reaches out to the database, and databases are notorious for SQL injections. SQL injections are basically software security vulnerability where you take user input from an untrusted source, and you do perform string concatenation with the SQL query that you're going to send to the database, meaning that the values are not actually treated as values, they're actually treated as SQL statements. Therefore, the provider of that untrusted input can hijack the statement and take control of your database. That can even result into taking control over the machine on which the database is hosted. That is really dependent on the database management engine. For example, some databases will have functions that allow you to execute shell commands, which is like the most basic, most rudimentary but effective way to take control over the system. Now, a good deployment of a database, if that function is not strictly needed, is going to restrict that function, is basically going to disable it. So that's one way that you can also target a botnet. Defenders, what they can do, they can use prepared statements, and this is not only about botnets, it's also about software in general. Like whatever software you do when you're communicating with SQL based databases, you need to prepare those values. They need to basically prepared statements. You're annotating that certain values, the user input, is going to be treated as values and not as SQL statements. The example of that could be, for example, you have your database library, and then you do raw query, and then inside of it you do string concatenation, where you say select everything from, I don't know, agents. Agents is a table in a database where ID equals, and then we do string concatenation, and then we provide a variable ID that's defined and passed by the user. So this is vulnerability. However, what database engines allow us to do is to do a question mark, and then in that function we prepare, we make the statement prepared. So basically we can say pass ID here. So in that sense, that ID will never be treated as a value. Of course, there are other vulnerabilities that you can leverage. This is just, it's really the most common thing, but I don't see it being eradicated anytime soon. I think just the nature of humans and databases and design choices, I think we are stuck with that. It just, as a developer, as you progress, as you advance, you're gonna get aware of those things, and trust me, throughout my career I have seen people that are senior engineers that make those mistakes, and that's fine. Most of the times we're all humans. If you have a good software development lifecycle, those kind of things will be caught by your peers that are peer reviewing your pull request, and maybe that's gonna be caught by static code analysis. Usually when you're building software, you need those kind of tools that are going to see that string concatenation passed as a statement to the database, and they're gonna flag it. There are other things that you can do, but let's move on to other stuff. So here we mentioned there are multiple things that you can use for communication. This is the most basic model. Now let's see how a threat actor can defend against such things. Well, first of all, they can use something known as Tor. Tor is a proxy service. It's free and open source, and it's managed by community. And what Tor does is it's a kind of like a VPN, and I'm going to explain what VPN is. But basically you're gonna send your internet traffic to Tor. Tor is gonna route that traffic around the globe, and then it's gonna reach the destination. So the destination is not gonna know what actually your IP address is. So if I connect to YouTube through Tor, YouTube is not gonna see my IP address. It's going to see the IP address of the server, which is known as Tor exit node. And let me explain a bit how Tor works in that regard. So we have three nodes. First, you have the guard node. That's a node that doesn't change that often, because if you hop too many times to different guards, then you might run into malicious node, because malicious node can do all sorts of things to you that I encourage you to Google and get deeper into this technology if you're going to use it, and it's good for you to understand it. It's good, like Tor is not just for malicious use. Majority of users use it to just browse the web. Like I use it when I'm just browsing the web. And basically, you're gonna, so this is you, and you're connecting to the guard node, and guard node is not gonna change that often, but it is going to change, and then it's going to basically go to another node that's gonna relay that traffic to a exit node, and then that goes into, for example, YouTube. So that goes into YouTube, or it might go into the C2 server. However, this is problem for the threat actor, because the threat actor doesn't want the server IP to be known, and Tor allows you to host something that's called an onion service. And an onion service is basically same as you, as a Tor user. It's hosting its website through Tor. So basically what happens, instead of connecting directly, is gonna have a guard node of its own. And is gonna have a relay node. And in this case, when you're connecting to the onion service, there is not an exit node because it doesn't exit the Tor network. So you're gonna have another node that we're going to call relay. And these two nodes are meeting here, and this is called rendezvous point, which is basically you don't know the IP of the server, and the server doesn't know the IP of you. And all of the traffic is going through 3 different servers. And there is something that you have to keep in mind. This relay doesn't know about you. And this relay doesn't know about your Tor guard. And so on and so on. So there are multiple layers of encryption and obfuscation of your origin. So this is basically what's happening when you're connecting through Tor. It goes like this. So I'm going to simplify the diagram by not displaying this and just displaying this Tor as a magical cloud. So I'm going to delete these for the time being. So this is another thing that threat actors use to obfuscate their origin, or to have kind of a fallback connection. For example, let's say that usually the agent will connect to the C2 server, which is on IP address of 123.123.123, and it's behind the domain, which is xyz.I am a bad guy. So let's say that you're a good guy and you're taking this botnet down. Well, you can work with the DNS providers, take control of that domain. Then you talk to ISPs all around the world, usually the one that's in charge of this IP, because there is a finite amount of IPs, because IP can be from 0 to 255 dot, then the same number, then dot, then the same number, then dot, then the same number, which basically means that there are, I don't know, millions, billions, however, not enough of IP addresses. But that's a bit out of scope of what we are talking right now. So you took control of this IP, and then the agent activates the fallback communication channel, which is Tor, and that will be basically 56 character .onion domain. So basically there are going to be 56 letters .onion. And what is this? What is this domain? Well, it's not in the control of the traditional centralized DNS providers. Tor has their own routing and DNS resolution servers and mechanisms, which is basically meaning that these first 56 characters are encoded public key of the onion service. And public key is referring to public key cryptography, which is a way to encrypt traffic end to end, meaning that given that you have a proper, valid onion domain, you will be connecting to the right onion service, which is not necessarily the case with traditional domains. There are many hacks that can convince computers where that domain is. So this domain will usually point to the IP address of a bad guy, but you as a good guy, you have your own IP address, and then the DNS provider points to your IP. However, here, this domain resolution is decentralized, meaning that when you're creating an onion service, you're going to create the public key and announce it to the world. Because Tor has something called Tor directory, which is basically a fancy way to say a list of known onion domains. So this way, the good guys are unable to act upon this one. However, something that you can do in your corporate environment or even at home, if you are not using Tor, you can simply get a hold of services, usually there are many, that provide a list of IP addresses and servers that are enabling the Tor network, which is just basically a group of majority volunteers that are philanthropic. They just want to help people have a tool of privacy. Tool is good, like Tor itself is good. It's the attention that might be malicious to use it and abuse it. So don't be pointing fingers at Tor, saying that it's the bad thing and it needs to be shut down, because they will just find another way to do the same, and you will limit the tool for people who really need it, like journalists in oppressed regimes or whistleblowers, etc. People that really need a way to securely communicate and do it in an anonymous way. So in this case, you can block Tor network and voila, you have secured yourself against Tor. Usually it's a bit more complicated than that, but usually if you block a lot of IPs that are related to Tor, you can cripple the agent's ability to communicate effectively. Alright, you have taken the DNS, and now what? Well, agents have another fallback channel, which is something known as domain generation algorithms, which is basically you have an algorithm that's gonna produce a string, a piece of text, and is gonna produce a lot of them, like maybe thousands of them, and they might be like some string that's produced .com or .net or .com and .net, etc., where basically it's gonna produce domain like this, .com, and maybe the same thing but .net, and maybe the same thing but .org, and when the traditional communication with the C2 doesn't work and the Tor network is not available, the agent might fall back onto domain generation algorithm. Let's write it here. Where basically it's gonna reach out to this domain and see if it's registered, and if it is, it's gonna treat it as a valid C2 server. So this domain that's registered by the bad guy can point back to this malicious IP where the C2 server is actually hosted. So you as a good guy, you can do multiple things against this kind of method. First, this is super suspicious. Like this kind of domain, like, oh my god. There are tools that are going to look at this domain and say that, oh my god, this is a string that's full of entropy, like it's just rubbish letters, I'm gonna block it by default. If it's malicious or not, I'm gonna block it. So that's one thing that you can do about it. However, the bad guys can be more smart about it, and they can take all kinds of words from a dictionary and generate domains that actually sound like something that's valid. Let's say that it's football sky red. Like something like this can exist. Looks a bit sketchy, but the thing is, those kind of smarter domain generation algorithms will generate multiple combinations of this kind of a thing, and not all of them will look suspicious. Thus, you cannot block all of them automatically. It's not that easy. So what you can do in that regard, once it's registered, well, one thing that you can do, you go to the DNS guys and say, this is the algorithm, I can predict through time what kind of domains are going to be generated and tried to be reaching out to, so can you just register all of these domains for me? And usually DNS providers will say yes, except if the bad guys are smarter and they do something like this. The DNS provider gonna go like, well, a customer might register that domain because that domain looks kind of valid, and I cannot just register like thousands and thousands of domain each day that my customers might want and give it to you, which is a valid concern. So in that case, what you can do is take out your wallet, get funding, and start buying those domains. So let's say that you bought this domain before the bad guy. You anticipated this, you reverse engineered the malware, you understood that it's gonna reach out to this, and you want to completely deny access to the C2 server. Well, you registered this, and now this is pointing to your IP address. Well, there is some things that bad guy can still do about that. So first of all, even though that, for example, Tor is going to perform some encryption on top of the communication, that is not true for the regular one here, which means that more often than not, the threat actor has created their own mechanisms to ensure that the traffic stays secure. So what they're going to do is they're gonna have something called private key. And they're gonna use that private key to sign all of the communication and all of the commands that are issued to the agents. And agents on their side have the public key of the C2 server. It's embedded into their code. They have this public key, and when a message comes from the C2 server, doesn't matter through which channel, the agent can verify it through the public key. And because we still don't have quantum computers that can break public key cryptography, you cannot derive the private key from the public key. Which means that even if you get that generated algorithm to point to your IP address, to your server, you still cannot issue commands, you cannot clean the machine from the infection, and the agent, the virus might just register a I mean, it might understand that you're not a valid C2 server because you're not replying with valid commands, and it might just disregard you. So some agents are implementing the cryptography, but sometimes, usually in the past, not today, when they have something that points to a valid server, and if the server just goes like, I don't have messages right now, even though that there is no encryption like applied, like if the message is nothing that is signed is sent because there is nothing to send, like the messages are empty, so I'm just gonna reply with 204, which means no content, and the agent might go like, oh, like I'm just gonna wait and reach out more. But sometimes agents nonetheless, even in empty responses, require you to maybe put in the response headers something that will let them know that this is the real deal, this is the C2 server that has the private key, or they have a special endpoint which is just basically encrypt current date with the private key so that I can verify it with the public key. Stuff like that can be used to verify the legitimate nature of the server. In that regard, you're screwed. It's just gonna start generating more domains, and it's gonna start to reach out to other servers. So in that regard, this just doesn't do anything for you. You have to go to ISP guys and take that IP address down. For this first lecture, that will be it. In the future, I'm going to present you what the threat actor can do about all of this and what you can do about all of this.